We have deliberately decided not to have any pre-prepared graphical representation of the situation because I want to give you a feel as if how you would do in a typical examination situation. So in such case, what you can have here is tan inverse x by a. Tan inverse x by a. Region is done. How long does it take? Not more than 10 seconds rather. So therefore this area is absolutely done. Now you want to travel from x-axis, which is y is equal to 0 line, to this particular line, which is y is equal to x line. So this becomes very easy to handle. In order to avoid any lack of clarity, I would move to the next slide. That's all. Otherwise I can write the answer here itself. This is almost done. So you will get 7 marks if you crack this. Now let's look at one more typical problem from the university model question paper. Now here we have deliberately decided not to have any pre-prepared graphical representation of the situation because I want to give you a feel as if how you would do in a typical examination situation. You need not have to spend more than 5 or 6 minutes for this particular problem. But the only thing that you require as far as this problem is concerned is how to integrate this particular form. That is, if you are given to integrate 1 divided by a square plus x square dx, what exactly you will get. Remember, we have discussed this in many situations previously. Of course, you need to have a here. You cannot have the numerator with only 1. So in such case, what you can have here is tan inverse x by a. Tan inverse x by a. Whenever you integrate 1 by a square plus x square, you get 1 by a tan inverse x by a. So this, if you remember, you would be able to solve this typical problem. Let's look at this particular problem, how exactly you begin solving this. First look at the inner integral and the limits, and then the sketch the area over which you carry out the integration. So how would I do that? This is my x-axis, this is my y-axis. In the examination, try to do a very simple but effective sketch. So here you are incepting with x is equal to y because your integration is first with respect to x. So your limits are defined for x. So one of the lines that you're talking about is this, a 45-degree line, because if you observe the limits, it is x is equal to y. So that is your first limit. And then x is equal to a. How do you represent a line? X is equal to a. That is, you're talking about the coordinates a comma 0 here. And since it's a 45-degree line, this point is quite easy because if x is a, y also has to be a. Your region is done. How long does it take? Not more than 10 seconds rather. So therefore this area is absolutely done. Now the thing is you want to change from x being first to y being first. So how do you go about? Y to x, you will be traveling vertically because here you first started horizontally because you started with x equal to y line, then you hit x equal to a line. So therefore these were the limits, but now you want to travel from x-axis, which is y is equal to 0 line, to this particular line, which is y is equal to x line, right? And then what about the outer limits? Here the minimum and the maximum values of y were 0 to a. That is, minimum value of y is 0, maximum value of a y is a. That is why you got 0 to a. But if we apply it to x also, it is same, because 0 to a, because this is a 45-degree line, it makes no difference. So can I write my new integral? It's quite easy. I can write my new integral. This does not change because of the symmetry. 45-degree line, the extreme values of x are 0 to a, which you would put here, or whether if you are looking at the extreme values of y, that is also 0 to a, which you will put here. But now since you are changing from y to x, now what happens, my extreme values are 0 to a, that of x, because x becomes my second integral. And what about the limits of y? Because in order to get the limits of y, I will have to travel vertically from y axis, rather x axis. The definition of x axis is y equal to 0, and I will be going all the way to this straight line. Since the order of integration first is y, the limits are going to be obviously defined in terms of x. Remember that always. A very trivial observation, but got to be in place. So now this is going to be x divided by x square plus y square, and here you have dy and dx. So this is the integral that you need to evaluate. But one thing you got to be very careful here, don't get scared. You have got x square, y square, there is no constant. How would I evaluate? Because when you are integrating with respect to y, what is to be kept constant? The x term has to be kept constant. So this is equivalent to saying this particular thing. You have got a square, a here. Fortunately, you don't have to multiply and divide by a also, because it is readily provided for you. X is a constant when you are integrating for y. So this is exactly of the form a square a by a square plus x square. But of course, x here is y, right? So this becomes very, very easy to handle. In order to avoid any lack of clarity, I would move to the next slide. That's all. Otherwise, I can write the answer here itself. This is almost done. So you will get 7 marks if you crack this. So therefore, what happens? The limits are 0 to a, and then here you are starting from what line? You are starting from the y-axis and then going all the way to the x equal to y line. So since your integration is first with respect to y, your limits are defined in terms of x. So therefore, x divided by x square plus y square dy, and this entire thing is going to be integrated with respect to x. Clear? So now this is of the form a divided by a square plus y square. So remember, the formula is tan inverse x by a. So it is y by x, y by x. You don't even have to multiply and divide by a, because it is already given here. So the limits of this are going to be 0 and x, okay, and then 0 to a, and then dx. So it's quite easy, because the moment you substitute the upper limit, tan inverse of 1 is 45 degrees, which is pi by 4. You always have to write in radians, don't write in degrees, because you are integrating. And then when you put y is equal to 0, tan 0 is 0, tan inverse 0 is 0, because tan 0 is 0. So therefore, what you get is pi by 4. When you integrate a constant, you get pi by 4 into x. The limits are a and 0, the upper limit. So therefore, can I write it here? Pi by 4 into x you will get, and the limits are 0 to a here, and that gives you pi a by 4. That's all. Pi a by 4 is what you get, because you are actually getting, you are actually integrating a function whose denominator is dominating than the numerator. That is why you get a smaller number towards the end. So therefore, let me walk you through what exactly I did. So this was my question. So all that I do in an examination, first write a neat sketch by considering the limits of the inner integral, which actually is with respect to x. So my definition is x equal to y, x equal to a. So x equal to a is this vertical straight line, and y is equal to x is this inclined straight line. That is why in the PDF that we have included, it is not just the integrals, we also have defined several elements of coordinate geometry, so that any given figure you should be able to construct. So y is equal to x is a straight line through the origin with 45 degree slope, and x equal to a is a vertical straight line. So therefore, this becomes your area of integration, that is over which this function is going to be integrated. Now if you change the order, the first integration is with respect to y and the subsequent integration with respect to x, it becomes very simple. You're traveling vertically from the y-axis, that is the x-axis, to y is equal to x. So x-axis is defined by y is equal to 0 line, and y is equal to x line is defined by y is equal to x. So therefore rather the value of y is x. All right, and then what happens, you are going to travel horizontally. That is, after y you are going to travel, consider the limits of extreme limits of x. Minimum is 0, the maximum is a, because the point where both these lines coincide are a comma a, because it's a 45-degree line. If your x coordinate is a, y also has to be a. So therefore you get this integral. And I told you very clearly, a by a square plus x square dx, if you integrate, you will get this, because when you differentiate this, you get back to this, right? It's we have done this several times. So here, when you are integrating with respect to y, x is constant. So it is of the form a by a square plus x square. You don't even have to multiply and divide by a as I did here for a general case. So therefore what happens, this readily becomes tan inverse y by x, because y is x is replaced by y and a is replaced by x. So the answer that you get is tan inverse x by a there. Here it is y by x, because x is replaced by a is replaced by x and x is replaced by y. So tan inverse y by x, if you substitute the upper limit x, what happens, it becomes tan inverse 1, which is 45 degree. Because it has to be written in radians, we have written it as pi by 4. And lower limit, y is replaced by 0, tan inverse 0, which is 0. So you get only pi by 4. And when you integrate pi by 4 with respect to x, you get pi by 4 into x. And the limits are 0 to a. And when you substitute that, you get pi a by 4. So that was a very, very easy one. Let's move on and look at one more discussion. Well, engineering and math are absolutely inseparable. We interventions day in and day out try our level best to make math as simple as possible and also of great practical value to every aspiring engineer. Do you want us to reach the masses? Please like us, share and subscribe. Do not forget to turn on the bell icon.